The objective today is to describe what and why a person would use a virtual LAN. So you'll typically see these abbreviated as VLANs, and what these are a broadcast domain that is partitioned and isolated in a computer network at the data link layer, which is OSI layer 2. So at this point in the class, you should be pretty familiar with this stuff, and when you see the data link layer being mentioned right here, that is one above the physical layer. So what that's saying is the VLAN is not a physical thing, it's a data link thing. So this extra LAN or this other network is not dependent on any physical devices. It's the opposite of that song, Let's Get Physical. It is not getting physical. It is more like a Vulcan, very logical. And when you think of this word virtual, whether you're dealing with a virtual machine, this word virtual always seems to relate to the word like simulation or simulated. Java has these bytecodes, which are like simulated versions of opcodes. The JVM is pretending to be a little CPU in and of itself right there. A virtual operating system is pretending to be an operating system on top of an operating system you already have. Just like a virtual LAN is pretending to be a network on top of a network you already have. So don't forget what LAN is an abbreviation of a local area network, and in this context, virtual refers to a physical object recreated and altered by additional logic. So basically what I've just been saying, put all of that into your own words. And if you need help doing so, there's a sentence starter. So a physical LAN, that is a small network, can be altered by having a VLAN added to it. VLANs work by applying tags to network frames and handling these tags in networking systems. Remember, frames are sort of like packets, just another layer down the OSI model. So these digital frames are getting a tag added to it. Some extra ones and zeros on top of all the ones and zeros it already has. And this creates the appearance and functionality of network traffic that is physically on a single network, but it acts as if it is split between two separate networks, or I should say two or more networks. Now normally you'd see another switch to create two LANs, but with a VLAN I can save some money on the physical devices such as a switch and just use logic to create another network. And then I can control these networks with a variety of different decisions. So if I'm looking at this mess over here, this is just a typical like LAN network diagram. I could get rid of this router and switch and just have everything go through this router. And when we're talking really large scales, we're talking about quite a bit of money being saved. Not to mention how much easier it'd be to wire all that stuff up. So maybe I want a network for entertainment-related activities at my home or a business, and so it'd be logical to go ahead and try to separate those two networks. I think I have a good question here for you to go ahead and make an inference to, like what are some reasons you might want to separate one network into multiple networks? And down below here I put a little hint, like for me as a parent, it would be nice to separate the things I need to do for work from my children's entertainment in case my children need to focus on their own work or just spend less time on the internet. So I have fun with making that inference. On this slide it says in this way VLANs can keep network applications separate despite being connected to the same physical network and without requiring multiple sets of cabling and networking devices to be deployed. And here's another twist to this concept. VLANs allow network administrators to group hosts together even if the hosts are not directly connected to the same network switch. So that's kind of redundant from what I've already said, but I thought I'd add this nice picture to your mind so you can like visualize maybe a need for this. Because VLAN membership can be configured through software, this can greatly simplify network design and deployment. If for whatever reason the boss doesn't want all the sales team on one floor, but maybe a sales team member is over here and then marketing is somewhere else, we don't have to go around and physically unplug wires or create switches to deal with the differences in these network segmentations. All you have to do is just make some configuration changes. So VLANs are really neat. And think about this, without VLANs, grouping hosts according to their resource needs necessitates the labor of relocating nodes or rewiring data links. We are saving time here, people, and not only is time money, but time is the one thing you cannot purchase. So your answer to this previous question may have mentioned something like that, like why would you want devices connected to other switches to be on a particular network? Or if you can do your administration from a computer rather than physically going out there and changing up wires, I think that'd be worth your time. Worth your time to learn so you can save time in the future. So many internet hosting services use VLANs, so now we're talking at like a much larger scale. What these VLANs are doing, separating their customers' private zones from each other, allowing each customer's servers to be grouped together in a single network segment while being located anywhere in that data center. So the question here is, who's really utilizing VLANs to their maximum amount of money-saving potential? Now, some precautions are needed to prevent traffic from escaping. An exploit known as Vlan hopping, so you'd have to be mindful of that. It always seems like with more convenience comes less security, so you need to try to balance that. And when I'm looking at big buildings like this, I'm imagining a lot of opportunities for things to escape, one of which is data. So to subdivide a network into VLANs, one configures network equipment. Simpler equipment can partition only per physical port, so you'd have to be careful what you buy here. And in this case, each VLAN must be connected to a dedicated network cable. So if you're going cheap with your switch, you're only halfway there with the opportunity to save yourself some heartache. Now, more sophisticated devices can mark frames through VLAN tagging so that a single interconnect, which we call a trunk, may be used to transport data for multiple VLANs. So what's the difference between a simple and a sophisticated VLAN? Now, since VLANs share bandwidth, a VLAN trunk can use link aggregation, quality of service prioritization, or both to route data efficiently. Network architects set up VLANs to provide network segmentation. Routers between VLANs filter broadcast traffic, they enhance network security, they perform address summarization, and they mitigate network congestion. So of all these concepts, which one do you think this picture is applying to? And for the sake of an introductory video like this, I think this is going to be a good enough takeaway for these two paragraphs. But if you want to learn more, I do have videos on quality of service, the concept of broadcasting traffic and filtering that traffic, and then a video on mitigating network congestion. So in a network utilizing broadcasts for service discovery, address assignment, and resolution and other services, what's going to happen is as the number of peers on a network grows, the frequency of broadcasts also increases. Broadcasts are very helpful, but if we can keep the number of hosts in a controlled logical range, then that is a good thing. And for it to help us in this specific way, it's doing something called forming multiple broadcast domains. So there's a great vocab sentence for you to remember, forming multiple broadcast domains. Like, just try to wrap your mind around what a broadcast domain, and here's another hint for you as to what this picture was referring to. Now, if you're looking for some extra credit, go ahead and tell me about this concept called service discovery. But for this lesson, that will be it. I just want you to describe what a VLAN is and why a person would possibly ever want to use a virtual LAN.